Hello, I would like to thank everybody for their time. My name is Luboš Řehounek and I would like to talk about bar-supported and unsupported dental implants, or splinted and unsplinted dental implants, a QCT-FEA study in the human maxilla. The goal of my analysis is to assess stress distributions in both bone at the peri-implant area and also in the implants by means of numerical analyses. The subjects of my analysis are the two pictures you can see in the middle of your screen. The one on the left is a supported or splinted implant assembly, and the variant on the right is not connected by any bars. It is the unsplinted variant. The goal is to inform a local dentist about the possibilities of mechanical finder and perhaps to extend this into a more complex and coherent analysis that involves a more complex model with the unsplinted and splinted implant assemblies. My assumptions going into this analysis is that the stress, both in bone and the implant assembly, will be preferable in the splinted variant. The splinted variant is at least supposed to be better because it has bars acting as stirrups which connect the implants together for a better distribution of masticatory forces. Also, according to literature, it has 97% survival rate 7 years following operation. It provides excellent anti-rotational stability because the implants are connected. It doesn't require too much maintenance and is also not significantly correlated with plaque accumulation, bone loss, or peri-implantitis. On the other hand, it is more expensive and more time-intensive to manufacture. Usually it is not needed in the mandible, but due to worse bone conditions in the maxilla, it is very often needed there. The unsplinted variant, on the other hand, has some cons. It wears out over time. Its osseointegration is reported to be worse, but on the other hand, it is less expensive, but also has more reported maintenance. However, there has been no significant bone loss as compared to the splinted variant reported in the literature so far, and the mechanical behavior of the unsplinted variant remains questionable because it is, in my opinion, supposed to perform worse, but there is no clinical data that supports this or the other opinion, so we have to find out. As to my numerical analysis, I carried two analyses out on a section of the human maxilla. I'm sorry, there's mandible in the slide, but it is supposed to be maxilla. For the splinted and unsplinted variant, I utilized a fully inhomogeneous bone model and used a 600 Newton 40 degrees slanted force on one of the frontal implants, as you can see on the image on the bottom right. I also considered both material and geometric non-linearities. So here you can see the two variants side by side. The one on the left is the splinted variant or the bar-supported variant, and the one on the right is the unsupported or unsplinted variant. I made a section of the human skull, extracted a part of the maxilla, and fixed the top part of the maxilla, and after careful insertion of both implant assemblies so that they are exactly in the same position, I applied a 40 degrees slanted 600 Newton force. The time required to perform both these analyses was under 1 minute, which is actually quite impressive and excellent for this kind of a model, and also very beneficial in the view of the dentist because it doesn't require so much time. However, the meshing takes still about 1 hour per variant, which is, I believe, the most intensive part of this analysis. And I would like to mention that the analysis was carried out on a 2-year-old PC with a 8-core 16-thread Ryzen 7 5800X CPU and 64 gigabytes of 300 and 3200 MHz memory. The material models I used were the Kayak material model for bone, which has a Drucker-Prager yields criterion, and for the metal parts, for the implants, I used the mechanical properties of TI6AL4V titanium alloy and the von Mises yield criterion. This picture shows deformations. The first column is step number 1, the second column is step number 5, and the last column is step number 10, which is the end of the analysis. The top row is the splinted variant, which, as you can see, comparing to the bottom row, which is the unsplitted variant, has a lot less deformation, which is of course logical and predicted. And I would like to also mention that these deformations are magnified 50 times. Here we arrive at distributions of stresses in the bone. The splinted variant is the one on the top, because I think I have to mention, because the mesh of the implants has been taken out, so we can actually see the stress distributions of the bone. So as you can see on the pictures, the pools of stress concentrations are much larger for the bottom picture, for the unsplinted variant, and I chose to only display risk factor between 0 and 30%, so we can really see the differences between the stress distributions, because I think if I made it between 0 and 100%, we couldn't actually see that quite well, because most of the risk factor numbers are in this area between 0 and 30%. So we can already see that the splinted variant on the top performs much better. Here we arrive at distributions of stresses for the implants and the bars. As before, the splinted variant is on top, and observing the values and the pools of concentrations of the stresses, we can see that it performs much better as predicted. To conclude this little research, I think that the simulations led to the conclusions that these analyses are feasible, but in my opinion, the model for such cases needs to be more complex. So, for example, we would surely need to extract the teeth material from the maxilla so that we really only have the maxilla bone material and the teeth which are supposed to not be there because the patient is supposed to be edentulous. So the teeth material doesn't interfere with our simulations. The unsplinted variant will also have some additional stiffness provided by the overdenture, so regardless of the implant assembly being splinted or unsplinted, there's still additional stiffness provided by the overdenture. But the main question is how much additional stiffness will still be there, and I would like to ask you if anyone has some recommendation or any idea to this. And this brief analysis also might lead to a better research, a more complex one, on some other patient-specific calibrated CT scan. And it proves that splinted variants are better, yet also more expensive. I think that these simulations and other similar simulations can be performed in real time by dentists, but the meshing times still somewhat interfere with this idea and make it a little bit difficult to use, as the meshing times exceed the computation times a lot. But the use for research in this area is feasible, and I believe that if the model is made a little bit more complex, it can actually provide good insight into this problematics. With that, I would like to thank you for your attention, and I would be glad to answer any and all of your questions. Thank you.